Good morning, my dear students. Welcome to the discussion on the topic projection of solids. Under projection of solids, we are discussing now solids axis inclined to both the reference planes. Under solids axis inclined to both the reference planes, we are solving seventh problem. Under solids axis inclined to both the reference planes, we are discussing a problem on square pyramid resting on one of its triangular faces on HP and vertical plane containing the axis inclined to VP. Now we'll enter into the problem. The given problem is a square pyramid 40 mm base side and axis 70 mm long has a triangular face on the ground and the vertical plane containing the axis makes an angle of 45 degrees with the VP. Draw its projections. Take apex nearer to the VP. Now we'll extract the data from the problem. It is a square pyramid and its base is a square and four corners of the base say A, B, C, D joined to a single point called apex and it is denoted here O. So here OA, OB, OC, OD are slant lines connecting the corners of the base as well as apex of the pyramid. And the lateral surface of the square pyramid is surrounded by four triangular faces. The name of the object is square pyramid and its base side length is 40 mm, axis length is 70 mm, axis inclination with the principal planes is not given directly and conditions mentioned in the problem are the triangular face of the pyramid is on horizontal plane and vertical plane containing the axis makes an angle of 45 degrees with the VP and take apex nearer to the vertical plane. With this basic data, we need to draw the projection of the square pyramid. The solution for the given problem is divided into three stages. Stage 1, initial position assumption. Stage 2, keep triangular face of the pyramid on horizontal plane. Stage 3, keep vertical plane containing the axis makes inclination to the vertical plane. Then we'll move towards how we'll consider the initial position assumption for the given problem. For initial position assumption of the square pyramid, what we need to do here in the problem, it is mentioned that the square pyramid is resting on its triangular face on the horizontal plane. Then its axis is inclined to the horizontal plane. So for drawing the initial position of the object, we need to tilt the square pyramid such that its axis is perpendicular to the horizontal plane. If its axis is perpendicular to the horizontal plane means its base is parallel to the horizontal plane. If its base is parallel to the horizontal plane means in top you will get true shape of the base of a square pyramid, that is square. While drawing the top view of a base of a square pyramid, that is square, keep square pyramid's base side say CD perpendicular to the XY line, preferably right side. Why we need to keep square pyramid's base side CD perpendicular to the XY line in top view? Because in the second stage, we are going to tilt the square pyramid such that it is going to rest on its triangular face OCD on the horizontal plane. With that, we are keeping square pyramid's base side CD perpendicular to the XY line. With this basic information, we'll enter into the first stage solution of the given problem. In the first stage, we are assuming square pyramid is resting on its base on HP and axis parallel to VP. In this position of the square pyramid, we need to draw top view as well as front view. As a first step under stage 1 solution, draw XY line. After drawing XY line, then draw true shape of the base of a square pyramid, that is square in top view, keeping its side CD perpendicular to the XY line, preferably right side. So draw a line perpendicular to the XY line. Then place CD side on this perpendicular line. Complete the construction of the square, and the angle between two adjacent sides in a square is 90 degrees. Name the corners of the square, say A, B, C, D. Here, the side length of the square is 40 mm. After that, in top view, we are able to see slant lines, say OA, OB, OC, OD, in addition to the base of a square pyramid. So draw images of the slant lines in the top view. For that, locate the center of the base. O is the center of the base. Then join OA, OB, OC, OD. Here OA, OB, OC, OD are nothing but images of the slant lines in top view. With this we completed drawing top view of the square pyramid when it is resting on its base on HP and its axis is parallel to VP. Next step is drawing its corresponding front view. For drawing the front view in the simple position, draw projector through the top view points, namely A, B, C, D and O towards the vertical plane. Then name the points in the front view, say A dash, B dash, C dash, D dash. It is O1 dash and this is O dash. Here, O1 dash and O dash is the length of the axis. O dash and O1 dash is the length of the axis, which is equal to 70 mm. Then join O dash, A dash, O dash, C dash, B dash, D dash. This is the front view of the square pyramid when it is resting on its base on HP and axis parallel to VP. Here, the slant edge, say O dash B dash is visible, whereas O dash A dash slant edge is invisible. And here, the slant edge O dash C dash is visible and O dash D dash is invisible. The slant edge O dash B dash is going to hide the slant edge O dash A dash, and here the slant edge O dash C dash is going to hide the slant edge O dash D dash. Because the square pyramid is resting on its base on HP, that's why its base image, say B dash C dash, is on the XY line. With this we completed first stage solution. Then we'll move towards the second stage solution. In the second stage, we are tilting the square pyramid such that the triangular face, say OCD, is on the horizontal plane. If the triangular face OCD is on the horizontal plane, means its image falls on the XY line in front view. In the second stage, we need to reproduce the first stage front view into the second stage with the given condition. The given condition is the square pyramid is resting on its triangular face, say OCD is on the HP, so that it image in the front view, say O dash C dash D dash is on the XY line. That is, this O dash C dash D dash line to be on the XY line. So locate a point O dash on the XY line. Then O dash C dash as a radius with compass, O dash as a center, draw an arc on the XY line. Name this point as C dash D dash. Then we need to locate point A dash in the second stage. For that, take O dash A dash as a radius with compass, O dash as a center, draw an arc. In order to cut that arc, take C dash A dash as a radius, C dash as a center with compass, cut already drawn arc, Then locate the intersection point and name that intersection point as A dash. After that, join B dash O dash, B dash C dash, C dash O dash. After that, we need to locate O1 dash along C dash B dash line. For that, with compass, C dash O1 dash as a radius, C dash as a center, draw an arc on C dash B dash line. Name this point as O1 dash. Join O dash and O1 dash, and this line is a axis line. With this we completed reproducing the first stage front view into the second stage front view with the given condition. Then we'll move towards drawing the second stage top view. For drawing the second stage top view, what we need to do? Draw projectors through C dash, D dash, O1 dash, A dash, B dash and O dash towards the horizontal plane and draw its corresponding locus lines from the first stage top view points. Then draw locus lines from the first stage top view points. Then locate the intersection points. This is the projector coming through C dash and this is the locus line for C. Then name this intersection point as C1. Then this is the projector through D dash and this is the locus line for D. Then name this intersection point as D1. This is the projector through B dash and this is the locus line for B. Then name this intersection point as B1. And this is the projector through A dash and this is the locus line for A. Then name the intersection point as A1. This is projector through O dash and this is the locus line for O. So name this point as O1. And this is the projector through O1 dash and this is the locus line for O1. Then name this intersection point as O2. After locating the intersection points in the second stage top view, we need to join these points based on 3 steps. Before joining the intersection points in the second stage top view, first draw the direction of vision of the observer. This is the direction of vision of the observer for drawing the second stage top view. Then as a first step, join all outside points with continuous and dark lines. Here O1, A1, D1, C1 and B1 are the outside points and all these points to be joined with continuous and dark lines. Second step is identify the corner which is nearest to the observer. Here this corner say A dash and another corner B dash is nearer to the observer. So these corners containing all lines to be drawn as continuous and dark. Here O1 A1 continuous, O1 B1 continuous. Then A1 B1 points also to be joined with continuous and dark line. Then we'll move to the third step. Then identify the corner or corners furthest from the observer. Here C dash D dash corners are furthest from the observer. So these corners containing remaining all lines drawn as dashed lines. Here O1 D1 dashed line, O1 C1 also dashed line. Then O1 O2 is a axis line. With this we completed drawing second stage top view as well as second stage solution. Then we will move towards third stage solution. In the third stage solution, we will reproduce the second stage top view into the third stage such that the vertical plane contained in the axis say O1 O2 is to be inclined with an angle of 45 degrees to the vertical plane, and we need to consider the condition that the apex of the pyramid is to be taken nearer to the XY line. In order to easily reproduce the second stage top view into the third stage top view, we are enclosing the second stage top view into a rectangle, and with reference to the rectangle, we'll reproduce the second stage top view into the third stage top view. Draw 45 degrees inclination line to the XY line. Along this inclination line, the axis line comes, and to this inclination line, the shorter sides of the rectangle are perpendicular and longer sides of the rectangle are parallel. So reproduce the rectangle from second stage to the third stage. Then to this shorter side of the rectangle, the A1 B1 side is parallel and with this perpendicular distance. So with this perpendicular distance here, draw line parallel to the shorter side of a rectangle, and the O2 point, this O2 point containing this line is parallel to the shorter side of the rectangle with this perpendicular distance. So with that particular perpendicular distance, draw a line parallel to the shorter side, and this point is going to be O2. Then this is A1 and this is B1, this is D1 and this is C1, and this is going to be O1. Here we are considering the point that the apex of the pyramid is nearer to the vertical plane. Then simply join all these points based on the sequence of joining of the points in the second stage top view. With this, we completed drawing the third stage top view. Then we'll move towards drawing third stage front view. For that, draw projectors through D1, C1, B1, O1, A1 and O2 towards the vertical plane, and draw its corresponding locus lines through the second stage front view. Then locate the intersection points. This is the projector coming through D1 and this is the locus line for D dash. Then name this point as D1 dash, and this is the projector coming through C1 and this is the locus line for C dash. Then name this point as C1 dash. This is the projector through B1 and this is the locus line for B dash. Then name this point as B1 dash, and this is the projector through A1 and this is the locus line for A dash. Then name this point as A1 dash, and this is the projector through O1 and this is the locus line for O dash. Then name this point as O1 dash, and this is the projector through O2 and this is the locus line for O1 dash. Then name this point as O2 dash. After locating the intersection points in the third stage front view, we need to join these intersection points based on 3 steps. Before joining the intersection points in the third stage front view, first we need to draw the direction of vision of the observer for drawing the front view. This is the direction of vision of the observer for drawing the front view. As a first step, join all outside points with continuous and dark lines. Here, D1 dash, C1 dash, O1 dash, B1 dash, A1 dash are outside points, and all these outside points are joined with continuous and dark lines. Then identify the corner which is nearest to the observer. Here the C1 corner is nearest to the observer. So this corner containing lines to be drawn as continuous and dark. So join C1 and B1 points with continuous and dark line. Then third step, identify the corner which is furthest from the observer. Here O1 corner is furthest from the observer. So this corner containing remaining all lines drawn as dashed lines. So join O1 dash as well as A1 dash with dashed line. After that, join O1 dash and O2 dash points with axis line. Finally, we need to check the drawing base edges as well as face edges. Here, A1 dash, B1 dash, B1 dash, C1 dash, C1 dash, D1 dash, D1 dash, A1 dash. That is, drawing base edges is over. Then O1 dash, A1 dash, O1 dash, B1 dash, O1 dash, C1 dash, O1 dash, D1 dash. That is, drawing face edges also over. Then O1 dash and O2 dash is the axis line. Then with this we completed drawing third stage front view. Then we'll see the pencil usage. Here the first stage top view as well as front view, second stage front view as well as top view, third stage top view as well as front view are with H pencil. The projectors are with 3H pencil. Dimensioning is with 2H pencil. Then we'll see dimensioning details. Here, the base side length of the square pyramid is 40 mm and axis height of the square pyramid is 70 mm. Here, all dimensions are in millimeters. In the third step, identify the corner which is furthest from the observer and draw remaining all lines from it as dashed lines. For the observer, C dash D dash corners are furthest. So C dash D dash corners containing remaining all lines to be drawn as dashed line. So join O1 D1 points with dashed line, O1 C1 points with dashed lines, and draw O1 O2 line as a axis line. Now we'll see overall summary of the solution. This is the first stage solution when the square pyramid is resting on its base on HP and its axis parallel to VP. This is the second stage solution. In this stage, the square pyramid is kept on its triangular face on HP so that its triangular face image falls on the XY line. Here, the triangular face image of OCD say O dash C dash D dash is kept on the XY line. Say O dash C dash D dash is on the XY line. Then completed drawing the second stage front view. From the second stage front view as well as first stage top view, projecting the second stage top view is completed. This is the third stage solution. In this stage, we reproduced the second stage top view into the third stage with the given condition. What is the given condition? The vertical plane containing the axis say O1, O2 is tilted with an angle of 45 degrees to the vertical plane. After reproducing the second stage top view into the third stage top view with the given condition, then projectors are drawn through the third stage top view point towards the vertical plane and corresponding locus lines are drawn from the second stage front view. With that we projected final stage front view. This is the final stage front view and this is the final stage top view. That's about the projection of square pyramid when it is resting on its triangular face on HP and vertical plane containing the axis inclined with an angle of 45 degrees to the VP and apex is nearer to the vertical plane. If you have any queries or doubts, you can write under comment section below this video. I'll clarify them. Visit again for more videos on engineering graphics using the links provided under description of this video. Keep learning and knowledge sharing. Thank you for watching.